Hello students, from today we are going to start the next chapter, sampling distributions. So this is our lecture 14 of our course STMJ 241. So in this lecture we are going to discuss three sampling distributions. Namely, first one is chi-square distribution, then second one is T distribution, and third one is F. So in this lecture, we will discuss the concepts of the sampling distribution. We will discuss all the corresponding results. Only we will not derive or we will not give the proofs of whatever the derivations are there. We will just discuss the concepts and theory of the sampling distribution. So let's start from the chi-square distribution. Content of the chi-square distribution is we will discuss all these topics. Let's start from definition of chi-square distribution. Definition of chi-square distribution. How to define this chi-square random variable? If x1, x2 up to xn are IID standard normal variates, then the distribution of summation xi square y is equal to summation xi square has chi-square with n degrees of, or it has also distribution gamma 1 by 2 comma n by 2 random variable. So chi-square distribution, it is defined as if xi's are IID normal 0 1 variates, then summation xi square follows chi-square with n degrees of freedom, or equivalently it is gamma 1 by 2 comma n by 2 distribution. So we will write the PDF of chi-square distribution with the help of this gamma distribution. Just instead of in the PDF of gamma alpha lambda, we will take alpha is equal to 1 by 2 and lambda is equal to n by 2 to write the PDF of chi-square distribution. So PDF of chi-square distribution. Next one is if x follows what is the PDF of gamma? PDF of gamma is if x follows gamma alpha comma lambda, its PDF is raised to lambda gamma lambda e raised to minus alpha x raised to lambda minus. Okay, so in this PDF, take alpha is equal to 1 by 2 and lambda is equal to n by 2. You will get the PDF of chi-square distribution. PDF of chi-square distribution. So its PDF will be f of x instead of alpha take 1 by 2 e raised to minus 1.6 raised to 2. Here is n is positive, x is also 0. So this is the PDF of chi-square distribution. Is denoted by, its notation is x follows chi-square with this n is its degrees of freedom. This is the parameter actually. Then mean, variance and mode. So we will just provide the statement or the formulas. We will not derive the mean, variance, mode and whatever the we will, because in this lecture we have to cover the three major topics: chi-square, t and e. Next is mean, variance and mode. So if x follows chi-square with n degrees of freedom, then its mean is, x follows chi-square with n degrees of freedom, then its variance is mode is n minus, so mean n, variance to n and mode is n minus, then mgf, cgf and gamma 1 and gamma 2. Next one is mgf of chi-square distribution. So if x follows chi-square with n, then its mgf is one minus 2t raised to minus n. So this t should be, define this mgf, this t should be less than 1 upon. This is the mgf. So with the help of this mgf, if we expand this, we will get the raw moments. Cgf is x of t, which is nothing but the log of this mxt, which is nothing but minus n log of 1 minus 2t. So by expanding this CGF, we will get the cumulants. With the help of cumulants, you can obtain central moments and you can find out the gamma 1 and gamma 2. So after expanding this, the cumulants will be, if you expand that CGF, you will get the cumulants value k1 is equals to en, to n, k3, at n, k4, 48. So by using the relations of these cumulants with central moments, we will get moments. So what is mu 1? Mu 1 is always 0. Mu 2 is k2. So mu 2 is equals to n. Mu 3 is k3. Again 8n. And mu 4 is equals to k4 plus 3 times k2 square. So if you solve this, you will get 48n plus 12n squared. And with the help of these central moments, we can find out the coefficient of and losses. So the beta 1 is nothing but mu 3 square upon mu 2 cube. To put the values of mu3 and mu2 by solving, we get 8 upon n. Therefore, gamma 1 is equal to square root of beta 1, 8 upon n is positive. So the interpretation is chi-square distribution is positively. If you observe here, for large n, if you take the limit of this gamma 1, it will be, this gamma 1 tends to 0. So for larger n, this chi-square distribution will tends to, this will be follows normal distribution. So sometimes it is also called as, for large n, it is the symmetric distribution for large n. And in general, chi-square distribution, it is positively skewed distribution. Next, beta 2. Beta 2 is mu 4 upon mu 2 square. Put the values mu 4 and mu 2, we get beta 2 is 3 plus 12. Gamma 2 is equal to beta 2 minus 3. So these 3 get cancelled. Gamma 2 is 12 upon n. The interpretation is chi-square distribution is left to go. That's it. Okay. Then next is use of chi-square table for calculation of probabilities. Normal approximation, Fisher approximation. The next one is use of chi-square. Calculation of probabilities. So the chi-square distribution is it is positively skewed. So its graph is, if you observe, its graph is the point is, it is denoted by, this is chi-square n comma alpha. This probability is alpha, and it is written as probability of chi-square. This is the graph of chi-square n. The probability of chi-square n greater than, this point is chi-square n comma alpha. Probability is, so we can get these probabilities of greater from the statistical table. So in the statistical table, the left corner, the first column is of degrees of freedom. Okay. In the inside, there are points, and at the top, there are the probabilities. So now, just now, you just keep, you just understand, to find out the probabilities for chi-square distribution, we get the probabilities of greater. Actual probabilities how to find, we will discuss the next lecture. The next lecture will be that is of the numericals. In that lecture, we will actually see how to find out the probabilities from statistical table. So just now, you just keep in mind that from chi-square distribution, you can find out the probabilities for this greater, chi-square greater than point, in this way. Next is normal approximation. That is, if Normal approximation is if x follows square with n degrees of freedom, then for large n, for large n, x minus expression of x divided by under root of variance of x, which is nothing but x minus n upon under root of 2n. This follows normal 0 comma. So if x is chi-square n, then for large n, the distribution of x minus n upon under root of 2n, this follows. This is the normal approximation. Now there is one more approximation for large n, that is Fisher's approximation. So Fisher approximation is if x follows chi-square with n, then for large n, under root of 2, here it is, you are taking x. If you are taking this y, the under root of 2y. Now here you can write under root of 2x minus 2n minus 1. This follows normal 0. So this is one more approximation which is called as Fisher approximation. We use it for the larger, and the last one is the additive property of chi-square distribution. Additive property statement is if x follows chi-square with n1, y follows chi-square with n2, and if x and y are independent, then x plus y follows chi-square with n1 plus n2 degrees of freedom. Its proof will be, we will prove this by MJ approach. Okay, right now we are not proving this. We are just in its statement. That's it for the chi-square distribution. Now let's discuss. Say similarly, whatever we have discussed for chi-square distribution, we will discuss now the same way theory and some concepts of T distribution. So let's start. Definition of T distribution. T. So how to define T distribution? Suppose we have the two independent random variables. One is u. Suppose we have u follows normal 0 1, v follows chi-square with n freedom, and u and v are independent. Independently distributed. Then T, it is defined as T distribution or T statistic is defined as T is equals to u upon under root v upon n. That is, which is nothing but normal 0 1 divided by normal 0 1 divided by under root of chi-square n upon n. This follows t with n. In this way, t distribution is defined. To define the t distribution, we need two independent random variables. One u is standard normal and another v is chi-square with n degrees of. Its PDF is PDF of f distribution. P of PDF of t distribution, it is defined as uh, is not P of f. It is t na. So P of as 1 upon under root n into 1 upon beta 1 by 2 comma multiplied by 1 upon 1 plus t square upon n is to n plus 1 upon range is minus infinity, n is positive. This is the PDF of t distribution. Notation is t follows t with n of. Then we will discuss its mean variance, central moments of odd order, central moments of even order. Its mean is, if t follows t with n degrees of freedom, then its mean is okay. So this distribution actually it is symmetric around this mean 0. T distribution is symmetric about its mean about mean t distribution हे symmetric असतं about त्याच्या mean ला म्हणजे 0 ला. Now variance of t distribution is, if t follows with n, then its variance is n upon n minus n is greater than central moments of odd order. We know that if any distribution, if it is symmetric, then its central moment of odd order will be 0. Mu 2r minus 1 is 0 as the distribution is symmetric. Therefore, mu 1, mu 3, mu 5 all odd order central moments are, or t distribution are 0. Then central moments even order. It is denoted by mu 2r, and it is defined as n is to r multiplied by n raised to r multiplied by beta. In the denominator it is beta 1 by 2. In the numerator it is beta 1 by 2 plus r. Here it is n by 2. So After putting the values of r equals to 1, 2, 3, 4, you will get the central moments of even order. So we will get, if you put r is equal to 1, we will get mu 2. If you put r is equal to 2, we will get the. So the central moments, therefore, now the central moments are mu 1 is we obtain 0, mu 2. If you put r is equal to 1 in the above formula, you will get the variance, which is n upon minus 2. Mu 3 also 0. And mu 4 is, if you put the value of r is equal to in this formula mu 2r, if you solve this, you will get mu 4, and it is 3n square divided by n minus 2 multiplied by n minus, this is the value of mu 4 for t distribution. So now next is coefficient of skewness and kurtosis. Once we get the center moments, we can easily find out the coefficient of skewness. So beta 1 is mu 3 upon mu 2 square. Mu 3 is 0, so beta 1 is 0. So beta 1 is 0, therefore gamma 1 is also. So the interpretation is t distribution is symmetric in nature. Beta 2 is mu 4 upon mu 2 square. If you solve this, mu 4 upon mu 2 square, you will get 3 plus 6 upon n minus. So gamma 2 is beta 2 minus 3, nothing but 6 upon n minus 4 is again positive. So the interpretation is t distribution is lepto. Okay, that's it. So the t distribution is symmetric and it is elliptical. So how it differ from the normal distribution? Normal distribution is also symmetric, but it is mesocritic. And the t distribution is symmetric, but it is leptocritic. The next concept is limiting distribution of limiting distribution of if t follows with n degrees of freedom, then as n tends to infinity, the probability distribution of t tends to normal 0. So for large n, t distribution tends to normal 0, comma. Now next is relation of this t with Cauchy. Relation with Cauchy distribution. So if x follows, or if t follows t with n degrees of freedom, then its PDF is what is the PDF? 1 upon under root n into 1 upon on beta 1 by 2 n by 2 multiplied by 1 upon 1 plus t square upon n raised to n plus 1 upon 2. So if you take n is equals to 1, so what is note here? In the PDF of t distribution with 1 degrees of freedom, we get f of x of t. This is 1, beta 1 by 2, 1 by 2. No, that will be root pi. If you solve this, you will get 1 upon, the final is 1 upon pi multiplied by 1 upon 1 plus square, which is the PDF of Cauchy distribution, standard Cauchy, which is the PDF of standard Cauchy distribution. Standard. So if t follows t with n, and if you take n is equal to 1, then that will be the PDF of standard Cauchy distribution. The last part of this t distribution is, that is the computation of probability. So t distribution is, its graph is symmetric and elliptic in nature. So this point is t with n comma alpha by 2. This point is minus t n comma alpha by 2. This probability is alpha by 2. This probability is alpha by 2. This is the graph of t with n. And in the statistical table, the probability is given are probability of mod t greater than t n comma alpha by 2 equals to. ठीक आहे. स्टॅटिस्टिकल टेबलमध्ये कुठल्या व्हॅल्यूज दिलेल्या आहेत, तर ह्या दोघांच्या प्रोबॅबिलिटीची सम करून ह्या व्हॅल्यूज दिलेल्या आहेत. कायस्क्वेअर डिस्ट्रीब्युशन मध्ये कसं होतं, तर त्या ठिकाणी फक्त अशा पद्धतीच्या ग्रेटरच्या प्रोबॅबिलिटीज अवेलेबल होत्या. या ठिकाणी ही प्रोबॅबिलिटी आणि ही प्रोबॅबिलिटी मिळून ह्या व्हॅल्यूज स्टॅटिस्टिकल टेबलमध्ये दिलेल्या आहेत. सो दिस वे the probabilities are given and we can find out from the statistical table. Actually, how to find the probabilities, we will solve the examples in our next lecture, which will be of. That's it. So this is over for t distribution, and now let's discuss about f distribution. Suppose we have two random variables, two independent random variables u and v, and both are chi-square. Suppose you follow chi-square with 1, v follows chi-square with n2. Both are independent. Then the ratio of two chi-square degrees of freedom, chi-square random variables, divided by their respective degrees of freedom, that is u divided by the freedom divided by b divided by its respective freedom equals to I square with n1 on its degrees of freedom n1 divided by I square with n2. This follows f with n1 comma 2 of this way we define f distribution. Its notation is first of all we'll write its PDF is n1 upon n2. Its PDF is n1 upon s2 n1 upon 2 divided by theta n1 by 2 comma by 2 multiplied by f raised to n1 by 2 minus 1 divided by 1 plus n1 upon n2 f is to n1 plus n2 n1 and 2 both are also again positive. Its notation is follows or f follows f with n1 comma. Okay, now let's sum its characterization mean variance. Its mean is if x follows or f follows f n1 n2 then its mean is n2 upon n2 minus 2 n2 is greater than 2. Variance is its variance is 2 into n2 square multiplied by n1 plus n2 is 2 divided by n1 multiplied by n2 minus 2 square into n2 minus 4. Condition is if this is defined if n2 is greater than then its mode of f distribution is n2 divided by n1 plus 2 multiplied by n1 minus 2. This is the mode of f distribution. Next is reciprocal property of f distribution. Property of f distribution. This property is if x follows f distribution with n1 comma n2 then 1 upon x f with n2 comma n1. This is a very important property. This will helpful in solving miracles. The very next result in finding the median and quartiles. This property is very much useful and in solving Numericals also, this property is also. Median and quartiles. For what? If x follows fnn. That is, if x follows f with n comma n. If n1 and n2 if both are same, that is if x follows f nn, then the median of the distribution is 1 and the quartiles are reciprocals of each other. That is q1 is equals to 1 upon quartiles are reciprocals of each. That's it. And the last is interrelations among T, F and chi-square distribution. Relations. There. T, F and first one is if P follows n degrees of freedom, then its square is T square. It follows F with. Its proof is very simple in the definition of T. If you take its square, you will get easily F1n. Second is very common, or which is directly from the definition of F. That is the ratio of two chi-square distribution divided by their respective degrees of freedom. Third one is if where take this as a u chi-square with 1. U and V are independent. Here you can also write earlier. That's it. The last is if F follows F n1 comma n2, then n1 F follows chi-square with n1, n2 tends to. So we have covered all the concept, all the statements of results, all the theory related to chi-square T and EF distribution. So in the next lecture we will discuss, or we will solve the numericals based on this sampling distribution. So that's it for today. Stop here. Thank you.